Okay, hello and welcome back. In this video we're covering 8.3 on the law of cosines. So this will be some additional techniques of solving non-right triangles. Last time we were doing that using the law of sines, and so there's similar equations that we can use that involve the cosine. So the law of cosines, we have three different definitions depending on which angle we start with. And so this is for any triangle. So we can imagine some non-right triangle, something like this. And let's call this angle A. So that would make this side length A. We can call this angle B. So I'll make this side length B, and angle C, side length C. So the law of cosines, it's kind of like the generalized Pythagorean theorem. It involves the three different side lengths and one of the angles. And we can express it in three different ways. So we can say c squared equals a squared plus b squared, and we get this additional term, minus 2ab cosine c. Or it could be solved for b. B squared equals a squared plus c squared minus 2ac cosine b. Or a squared equals b squared plus c squared minus 2bc cosine a. So you'll use one of these depending on what information you have, which angles and side lengths are available. And you can see a general pattern. If it starts with c squared, we have the two remaining side lengths, a squared plus b squared. So that kind of looks like the Pythagorean theorem. Then there's always a subtraction. There's always this 2. So 2ab, in this case, it's these two angles that show up again in the formula. Minus 2ab, and then the cosine of the angle that's opposite of this side length. So we see that same pattern. Say like for b squared, the remaining side lengths are a and c. And there's our a and c again, and then cosine of angle b, so the angle opposite that side length. And we see the same thing for a. So just little tricks on trying to remember these. And so we can solve both for angles and side lengths. And the benefit of using the law of cosines is that we don't get that ambiguous case where we might have two potential triangles, which we saw for the law of sines. So it can be a bit more direct. All right, let's just go through a few examples and practice using this in context. So our first example gives us two sides and one angle. And this was the one that kind of gave us trouble with the law of sines, where we had potentially two triangles to choose from. So let's apply one of these law of sines formulas, and we'll see which one we should choose. So I'll start out the same. I usually like to list our three angles and our three side lengths, and if we have them or not. Oops. So angle A is unknown, but we know side length A is 2. Angle B, also unknown, but we know side length B is 3. We know angle C is 60 degrees, and we don't know side length C. So let's start with finding that missing side length. We can begin there. So let's find side length C. So that means I'll use this first equation, which involves, it's already solved for c squared. We'll just end up taking the square root at the end. So let me write out the formula here first. It states that c squared equals a squared plus b squared minus 2ab times the cosine of angle C. So we have all of those other pieces of information, just need to plug in. So this would be equal to 2 squared plus 3 squared minus 2 times 3 times the cosine of 60 degrees. So that would be 4 plus 9 minus 12, and the cosine of 60 degrees, that's the cosine of pi over 3, is 1/2. So 4 plus 9 minus 6 is equal to 7. So c squared equals 7. We'll take the square root of both sides. Here we'll always take the positive square root. So we get that c is equal to the square root of 7. All right, let's try to find now our missing angles. We want to find, let's find angle B using the law of cosines. So I want to use the one that involves angle B. So that will be the second definition. That's solved for b squared. So we'll say b squared equals the other two angles, a squared plus c squared minus 2ac times the cosine of angle B. And we want to ultimately solve for that angle. So I'm going to just solve it generally first. I'm going to solve it for the cosine and then plug in our values. You can plug in the values first. I tend to just do that later, so there's less maybe potentials for having to round or anything like that. But let's just rearrange this and solve for the cosine. So I'm going to add it over to the left side. I'm going to add this 2ac cosine b to the left side. So it will appear positive here. 2ac times the cosine of b. And I'll subtract that b squared over to the right side. So this should equal a squared plus c squared minus b squared. And let's divide both sides by 2ac. So we get this expression, cosine of b equals a squared plus c squared minus b squared over 2 times a times c. So to find this angle, I would take the inverse cosine of both sides. So b would be equal to the inverse cosine of, and let's go ahead and plug in all our values. So a is 2, so 2 squared is 4. C squared would be the square root of 7 squared. So that'll just be 7. Minus b squared. B is 3, so 4 plus 7 minus 9. Over 2 times a times c, so 2 times 2 times the square root of 7. So if you have a calculator where you can just put all of that into an inverse cosine, that can be helpful, or you may want to find that value first and then input that answer into the inverse cosine. So plugging that all in, and be sure you're in degree mode, we should get that b is equal to 79.1 degrees. And with the law of cosines and with the inverse cosine, we don't need to try to consider a second angle. We had to do that with the law of sines because the output of the inverse sine was restricted between negative pi over 2 and positive pi over 2. And we're typically dealing with positive angles, so there was always some possible second angle in the second quadrant that would give us the same value of the sine. With the inverse cosine, the output is between 0 and pi. So between 0 and 180 degrees, and those are all the only possible angles that we could have within a triangle. So we will get our exact angle. We won't get some ambiguous angle where we have to consider some second option. So that's a benefit of the law of cosines. So we get our angle for B, 79.1 degrees. Now we're just missing angle A. So since we know angle C and angle B, we can just subtract both of those from 180 degrees. This one can be easy. We can say angle C should be 180 minus 60 degrees minus 79.1 degrees. So that will give you that C is equal to 40.9 degrees. So once you have two angles, you can just use that property that all angles within a triangle should sum up to 180 degrees. So we can also use this if we only know the sides of a triangle. So they call this the SSS triangle, or side, side, side. So let's write down what we know and what we need to know. We don't know any of the angles, but we know all of the side lengths. So A is 4, don't know angle B, but side length B is 3. Don't know angle C, but side length C is positive 6. So let's just start trying to find angle A. So let's use the version of the law of cosines that has angle A. So that's the one that starts with a squared. You can say a squared equals b squared plus c squared minus 2ab cosine c. And I'll be ultimately solving for that, cosine A. Yeah, put the wrong angle in there. So b squared plus c squared minus 2ab cosine A. So I want to be solving for that angle A inside of the cosine. So I'll first isolate that term. So I'll add it over to the left side, 2ab cosine A, and I'll subtract the a squared over, would equal b squared plus c squared minus a squared. And then I'll divide both sides by 2ab. So b squared plus c squared minus a squared over 2 times a times b. And then we would take the inverse cosine of both sides. So a should equal inverse cosine. Now I'll plug in my values. So b squared is 9. C squared is 36. A squared is 16, so minus 16, over 2 times a times b, so 2 times 4 times 3. So plug all of that in, and you should get that a is approximately equal to 36.3 degrees. And again, just be sure that you're in degree mode on your calculator. So now let's find side length B. So let's use the version of the law of cosines that involves angle B. Oh, I meant to say angle B here, not side length. That involves angle B. So that's the one that's solved for b squared. B squared equals a squared plus c squared minus 2ac times the cosine of angle B. And let's rearrange it. I'll do the same little maneuver. I'll add this over, subtract the b squared, divide by 2ac, and take the inverse cosine of both sides. Oh, and let's plug in our values now. So a squared is 16, c squared is 36, b squared is 9, 2 times a, which is 4, times c, which is 6. So evaluate the right side, and you should get b is about 26.4 degrees after rounding. And now let's find our third angle just by subtracting everything from 180. So angle C should be 180 degrees minus 36.3 degrees minus 26.4 degrees. So we get 117.3 degrees. So the law of cosines is nice. We don't get the ambiguous case. We can find everything directly. All right, let's look at one applied problem. So this is another sort of like nautical navigation problem. So it says a motorized sailboat leaves Naples, Florida, bound for Key West, 150 miles away. So let's imagine this is Naples. And then down here, let's call this Key West. And it says these are a distance of 150 miles. It says maintaining a constant speed of 15 miles per hour, but encountering heavy crosswinds and strong currents, the crew finds after 4 hours that the sailboat is off course by 20 degrees. So if they've wandered, say, like somewhere over here, where they have moved 20 degrees, let's say west. So that means this little angle in here we can call 20 degrees. So it asks us, how far is the sailboat from Key West at this time? So notice we're building a triangle. So the first thing it wants is this missing side length here. Let's call this side length C. We can call this one A, and this 150, let's call that B. So then that would make this angle B inside here. And this would be angle A. So it wants us to find first how far we are from Key West. Well, first we can find this side length A. We'll need that piece for sure. And we know that we were traveling, let's see, how fast did it say? 15 miles per hour. And this was after 4 hours. So we would just need to multiply those to find out how far we are. Because distance, we can describe that as the rate traveled times the amount of time that passes. So we'll call that distance A. So I'll say A should equal 15 miles per hour times 4 hours. That's a total of 60 miles. So let's use this information to find this side length C using the law of cosines. I can say C squared will equal A squared plus B squared minus 2AB cosine C. And C is this angle of 20 degrees because that's opposite from our side length C. And we're trying to solve here for C. So C squared would be A squared, so 60 squared plus B squared, 150 squared, minus 2AB, so minus 2 times 60 times 150, times the cosine of C, which is cosine of 20 degrees. So don't have to rearrange everything, just need to plug everything in and then take the square root of both sides. So 60 squared plus 150 squared minus 2 times 60 times 150 times the cosine of 20. Let's see, let me type this in once again. I think I might have forgotten to square some terms. 60 squared plus 150 squared minus 2 times 60 times 150 times the cosine of 20. And then I'll take the square root of the result. Yeah, I get 95.8 miles. Yeah, I got some negative number at first, so that was a sign I didn't type something in correctly. So we get one missing piece here. We know that we are 95.8 miles from Key West. So now it asks us, through what angle should the sailboat turn to correct its course? It's kind of a tricky question. It's not necessarily asking for angle B, although that's what we can find using the law of cosines. Because keep in mind, we're on this boat, and it's continuing on this path. So we want to turn in the direction of Key West. So it's actually looking for this angle here. Oops. So that inner angle. But if we find angle B, we can subtract it from 180 because this angle is the supplement of that angle. It's on a straight line, so we'll be able to find it indirectly. So let's start off by finding that angle B in our triangle. So let's use the version of the law of cosines. B squared equals a squared plus c squared minus 2ac times the cosine of this angle B, and that's what we want to solve for. So if we rearrange everything, I'll add the 2ac cosine B over, subtract that b squared, then I'll divide by 2ac, so a squared plus c squared minus b squared divided by 2ac. Then I'll take the inverse cosine of both sides, so b should be equal to the inverse cosine of, and this will be 60 squared plus 95.8 squared minus 150 squared, all over 2 times 60 times 95.8. So after we evaluate everything, you should get that B is equal to 147.2 degrees. So that's that inner angle. But we want this angle on the outside of the triangle. So we can find that, we can say theta equals 180 minus 147.2. We can find the supplement of that angle. And you should get 32.8. So that's how much we need to turn in the direction of Key West in order to get back on track. Part C asks us how much time has been added to the trip because of this. So let's assume that the speed remains at 15 miles per hour. So let's find out how much farther we're traveling. Normally we would have traveled just this straight 150 miles. So let's see how much more we need to travel in terms of miles, and we can find out how long that would take. So I'll do part C over here. So the boat will travel we did that 60 miles off course, and then plus the 95.8 miles, that's that side link C to get back to Key West. So that's a total of 155.8 miles. So it's 5.8 miles more than the direct route. Which was 150. So let's just find out, going 15 miles per hour, how long it'll take us to traverse 5.8 miles. So we can express, we said earlier distance equals rate times time, so we can divide rate over and say time equals distance divided by rate. So it's a distance of 5.8 miles divided by a rate of 15 miles per hour. And I get 0.39, and this is in hours. So if we want to express that in minutes, we just got to multiply by 60. So that gives us 23.2 minutes. So using the law of cosines in order to solve some distances, do a little triangulation involving a ship that is off course. All right, that's it for this section. So we introduced the law of cosines, solved a triangle that had two sides and one angle. Also a triangle where we only knew side lengths, we could find all the remaining angles, and then we got that applied problem at the end. So that's it for this video, and I'll see you next time.